Hello everyone, welcome to Control Systems lectures. In the last lecture, I discussed about stability of the system. And we had seen that the condition for a system to be stable is that if we are having any system, then all the poles of the closed loop transfer function, they should lie on the left hand side of the S-plane. Okay. So that is the basic criteria. That is, if you are having any transfer function, suppose we write the transfer function, it's a function of numerator and denominator. So the condition for stability is that the denominator, the roots of the denominator, they should all lie on the left hand side of the S-plane. So if this is the S-plane, then all the poles should lie on the left hand side of the S-plane. If that is the condition, then we say that the system is going to be stable. However, if any of the pole, if they lie on the hand side, even if one of the pole, if it lies on the right hand side of the S-plane, then the system is going to be unstable. And if the poles, they lie on the imaginary axis, then we say that the system is going to be marginally stable. But for the system to be stable, the condition is that all the poles should lie on the left hand side of the S-plane. That is the main criteria. So it's pretty simple. Like if you want to find out if you are given a function and you know the transfer function of it. Suppose I say that there is a transfer function which looks like something like 1 upon s plus 2 plus 1 upon s plus 3, okay, plus 1 upon s plus 4, something like this. Then you can easily find out that the response of the system, it's going to be, if you take the Laplace inverse of it, then it's going to be e to the power minus 2t plus e to the power minus 3t plus e to the power minus 4t. And if you plot these three curves, then definitely the output that you are getting, the natural response of the system, it's going to become 0 as time tends to infinity. Okay, so the natural response, if it decays to 0 as time tends to infinity, definitely the system is going to be a stable system. But what if there is one more pole added to it, something like s 1 upon s minus 2? Then due to this, if you take the inverse Laplace transform of this, it's going to become e to the power 2t. And if you plot this e to the power 2t, it's going to shoot at infinity as the time tends to infinity. So the system is going to become unbounded system. Although you are having three poles which are on the left hand side of the S-plane, easily you can see over here that first pole is lying at minus 2, second pole minus 3, third pole minus 4. So they are all lying on the left hand side of the S-plane, minus 2, minus 3, minus 4. But one of the pole, it is lying on the right hand side of the S-plane. And due to this one pole, even if all the poles, we have n number of poles which are lying on the left hand side, but even if one of the pole it's lying on the right hand side of the S-plane, then you can comment that the system is going to become unstable. So it's pretty simple. If you know this, then you can say that it's not really very difficult to find out the stability of the system, because you just have to find the roots of the denominator and determine whether they are lying on the left hand side or the right hand side. Okay, so what you have to do, you have the denominator, you have the equation of it, just find the roots of it, and you can easily find out the stability of the system. So when you know this, then why do we need any criteria? Like this Routh-Hurwitz criteria is basically used to determine the stability of the system. So if you want to find the stability of any system, you can use this criteria. What is the need of it? So what is the need? That's the first question that will come in your mind. So to determine the stability of the system, we need the information about the location of the closed loop poles of the system. That's pretty clear. But how can you determine the roots if the equation looks something like this? Like if you are given in some equation, a very higher order equation you can see over here. It's s to the power 8 plus 5s to the power 7, 4s to the power 6 and so on. So if you are given any equation like this, like if your system is containing higher or it's a higher order equation, LTI equation, then to determine the roots of this, actually to determine the roots above third polynomial means it becomes very difficult to find that also. So if the if it goes in higher order, then it becomes really difficult to find out the roots of the equation, and if you are not able to find the roots of the equation, how can you determine the stability of the system? That's one major big problem, and that's why this Routh-Hurwitz criteria it's needed. So what is Routh-Hurwitz criteria? I have written over here. It is basically a criteria which can determine the stability of the system without actually finding the roots of the equation. So if you are given this equation, you don't have to find all the roots of the equation. Definitely if this is a eighth order equation, you can see over here, that means the system is going to have 8 poles. This system will be having 8 poles, but you don't really have to find out all the 8 poles and determine whether these poles are lying on the right hand side or whether they're lying on the left hand side or whether they're lying on the imaginary axis. You don't really have to do that using this criteria. So it will be helpful in cases where the characteristic equation is a higher order polynomial. Okay, so that's the beauty of it, that you don't really have to find out the actual roots of the equation. Without even finding the actual roots, you can determine whether the system is stable or unstable. Okay, so we'll see how to do it, what are the steps to determine the stability of the function of any system which is given, where the transfer function is given. Okay, using Routh-Hurwitz criteria. Now I'm not going into the logic of how this criteria was formed, but if you want, then I can include that in the next lecture. Right now I'm only going to discuss how to determine the stability. Means I'm going to just illustrate the method. I'm not going into the I'm not going to the logic of the method. What is the logic behind it? Okay. So if you want, however, then you can just message me, or you can write it in the classroom, Google Classroom. I can definitely I'll take one lecture uh, explaining how this method actually works. Okay. So the steps to determine the stability using this Routh-Hurwitz criteria is, like, first of all, here I have given the step. First step is to check whether the polynomial, like you are given a polynomial, here only you can see you are given a polynomial. Okay, this is the polynomial that we are taking. So check whether all the coefficients have positive and real value. So whether all the coefficients are having positive and real value. You can see here that the complete equation, there is no negative coefficient. Coefficient means like s to the power 8, इसका coefficient क्या है? 1. S to the power 7, its coefficient is 5. S to the power 6, coefficient is 4. This coefficient is 1. Here 3. S cube 7. S square coefficient is 2. Here coefficient is 1, and this we can write it as s to the power 0, with coefficient as equal to 51. Now all the coefficients that you can see, 1, 5, 4, 1, 3, 7, 2, 1, 51. These are the coefficients that we can see over here. All are positive and all are real. So first condition is check whether the polynomial has all the coefficients having positive and real value. Yes, okay, here the answer is yes. Also see that all the coefficients have all coefficients having non-zero value. So whether there is any term missing over here, suppose for example, if this was missing, there was no s to the power 5, okay, in this equation, it was just like s to the power 8 plus 5s to the power 7 plus 4s to the power 6, and then there is no s to the power 5, then there is 3s to the power 4. Suppose some equation was given like that. So whether the equation is having any term with the coefficients value as 0, because this s to the power 5 will become 0, this term will get eliminated only if we can say that the coefficient is equal to 0, then this term can be eliminated. So whether any of the coefficient it's having the value 0 or all are non-zeros. So if any of the above condition is found to be false, like if any of the coefficient is having negative value, or it's not real, or it's having all coefficients, any of the coefficient is having value 0, if any of this condition is found to be false, then the system is definitely unstable. So this is the first way that you can find the stability of any system. So here you can see, if you are given any equation, just first of all look at the equation. Look at this is actually known as your characteristic equation. This is the characteristic equation that is given to you. This is representing like if you are having the transfer function equal to ns divided by ds. So this equation is the characteristic equation. That means it's ds is equal to 0. This becomes the characteristic equation. So the characteristic equation, this is given over here. Just look at the equation. Check whether all the coefficients are real. Then check whether all the coefficients are positive. And another thing that you have to check is whether all the coefficients are having non-zero value. Okay. If all these conditions are satisfied, if any of the condition is not satisfied, then you can say that the system is definitely unstable. But what if all the conditions are satisfied? So if all the condition, like both the condition, if they are true, then the system can be unstable, it can be stable, or it can be marginally stable. तो अगर ये कंडीशन सेटिस्फाई हो रही है तो हम नहीं प्रिडिक्ट कर सकते डायरेक्टली बाय सीइंग द इक्वेशन वेदर इट्स स्टेबल सिस्टम और अनस्टेबल. बट अगर इनमें से कोई भी कंडीशन फॉल्स होती है तो डेफिनेटली आपका सिस्टम जो है वो अनस्टेबल होगा. अच्छा, ऐसा भी हो सकता है like there it can be given like any equation, it's like s minus s cube minus 4s square minus 2s minus 1 equal to 0. Okay, so here you can say that all the coefficients they are having negative value, but what you can always do with it is that you can multiply minus 1 with this equation, and if you multiply it with minus 1, then what will happen, all the coefficients will become positive. So this won't be considered as a unstable system. If all the coefficients are negative, then you can always multiply minus 1 with it. Okay, hence the system will again become all the coefficients will again become positive. So in those cases you can't really say that the system is unstable. आपको अनस्टेबल तभी बोलना है जब कुछ पॉजिटिव हो कुछ नेगेटिव हो. अगर इस तरीके का सिस्टम दिख रहा है या कोई एक टर्म मिसिंग दिख रहा है इसकी पावर का, उस केस में आप डायरेक्टली बोल सकते हैं कि सिस्टम इज अनस्टेबल. बट इफ दीज कंडीशंस आर सेटिस्फाइड, देन व्हाट टू डू, then you have to determine the stability using Routh array. So Routh array is formed, and using that array you can determine the stability of the system. So the second step comes only when you have to determine whether the system is unstable, stable or marginally stable. So the formation of Routh array, how to form it. So we have taken a general polynomial equation over here. This is a generalized polynomial equation. जैसे अभी ये वाला equation देखा था. We have some coefficient s to the power 8 plus some coefficient s to the power 7 and so on. So any general equation can be written as a naught, where a naught is the coefficient of s to the power n, plus a1 s to the power n minus 1, a2 s to the power n minus 2 and so on. It can go till a n minus 1 s to the power 1 plus an. Here you can say write it as s to the power 0. So this can be your general polynomial equation. If such kind of equation is given, then the steps to find out the Routh array, first of all, first step is you have to make a column with powers of s starting from the highest power. So highest power in this equation you can see, इस equation में highest power of s क्या है? S to the power n. n आपका कोई भी integer है, n can be any integer. Okay. So the highest power of s will be s to the power n. So you have to make a column. आपको एक column बनाना पड़ेगा with powers of s starting from highest power of denominator and going up to s to the power 0. So what does this mean? Like first you'll write s to the power n because that's the highest. Next, starting from highest of the denominator and going up to s to the power 0. तो आप पहले s to the power n लिखेंगे, then s to the power n minus 1, then s to the power n minus 2 and so on. कहाँ तक जाना है आपको? पूरा कॉलम बनाना है going up to s to the power 0. So it will go up to s to the power 1 and then s to the power 0. So this is how first of all you just make the column. जैसे अभी ये पिछला जो एग्जाम्पल देखा था उसमें आपका था that equation was s to the power 8 plus something, suppose 7s to the power 7 plus 6s to the power 6 plus 4s to the power 5 ऐसे suppose दिया था and so on till s to the power 0 equal to 0. तो यहाँ पे हम क्या लिखते हैं? s to the power 8, s to the power 7, s to the power 6 going up to s to the power 1 and s to the power 0. This is how you have to write down the column. Next step is write the coefficients starting from highest power of s. So highest power of s is this one. Write the coefficient. अब आपको coefficient लिखना है. In the top two rows, तो ऊपर की दो rows हैं, उसमें आपको इनके coefficients लिखने हैं in the manner which is shown. So just see, first write a0 जो आपका highest coefficient है, highest s to the power है, उसका जो कोएफिशिएंट है जस्ट राइट दैट. नेक्स्ट राइट a1. तो ये जैसे आपका s टू द पावर 8 का 1 था तो आप यहाँ पे 1 लिखेंगे. नेक्स्ट s टू द पावर 7 का कोएफिशिएंट है 7, सो यू विल राइट a1 एज 7 ओवर हियर इफ दिस इज द एग्जांपल. ओके. नेक्स्ट a2. सो आप कैसे गए? पहला आपने यहाँ लिखा, दूसरा आप नीचे गए, तीसरा आपने फिर फर्स्ट रो में आपने कोएफिशिएंट डाला. नेक्स्ट अब जैसे यहाँ पे आपने इसका s टू द पावर 6 है, इसका कोएफिशिएंट 6 है, दिस 6 यू विल राइट ओवर हियर. सो द नेक्स्ट इज s टू द पावर 5, इसका कोएफिशिएंट 4 है तो यू विल राइट इट ओवर हियर. ओके. सो आर यू गेटिंग इट? यू हैव टू गो इन द zigzag पैटर्न. पहला, दूसरा, तीसरा, चौथा, फिफ्थ, सिक्स्थ एंड सो ऑन टिल s टू द पावर 0. आपको इस तरीके से zigzag पैटर्न में a4 then a5 then and so on. ओके. ये आप कब तक कहाँ तक लिखेंगे? जब तक आपका an नहीं आ जाता है. सपोज an comes over here. So this is how you have to write the coefficient. First of all you have to make two rows. ये rows कैसे बनेंगे? अब यहाँ पे आप देख सकते हो, आप ऐसे भी लिख सकते हो कि we are writing the coefficients, एक छोड़ करके दूसरा आप कोएफिशिएंट लिख रहे हैं. फर्स्ट इज a0, देन a2, देन a4, देन a6, देन a8, सेकेंड a1, a3, a5, a7 एंड सो ऑन. तो ऐसे भी समझ सकते हैं. सो यू हैव टू राइट दीज कोएफिशिएंट्स. ओके. सो टू रोज विल बी मेड. नेक्स्ट रो you have to form. So the next step is you will write b1 over here. But what is going to be this b1? ये b1 आपका क्या होगा? Okay. So this b1 is actually going to be, b1 will be equal to a1 a2 minus a0 a3 divided by a1. Okay. So the value of this b1 is going to be a1 a2. Okay. I'll just change. Okay. So B1 is actually A1 A2. So you have to multiply this A1 with A2 minus, okay, so this here you're going to multiply minus A naught A3. So A naught A3 इसको माइनस करना है. So multiplication of A naught A3 divided by A1. So divided by again A1. तो ये एक तरीके का 8 का सिंबल बनता है. 8 जैसा है वैसे आपको कोएफिशिएंट्स को मल्टीप्लाई, सब्ट्रैक्ट, मल्टीप्लाई एंड डिवाइड, these four operations have to be done. So A1 into A2 minus A0 into A3 divided by A1. This is going to be your B1. This is going to be the first coefficient of this third row. Similarly, अब यहाँ पे next आ जाएगा B2. And what is going to be this B2? I'll just change the color. So this B2 is going to be A1 A4 minus A0 A5 divided by A1. Now ये आप यहाँ पे अगर इसको चेक करेंगे तो ये 8 का जैसे मैंने बनाया था, it's going to expand. So it's basically A1 into A4, okay, this multiplied minus A0 into A5 divided by A1. So आपने 8 थोड़ा सा expand कर दिया है with multiplication, subtraction, again multiplication and then division. These four operations are going to be done. A1 into A4 minus A0 into A5 divided by A1. So this is going to be your B2. सिमिलरली अगर B3 निकालना है, अगर सपोज आगे B3 आता है सपोज यहाँ पे, तो वो क्या होता है A1 इंटू यहाँ पे आपका जैसे A6 होता है और ये A7 होता है, तो A1 इंटू A6 minus A0 into A7 divided by A1. Okay, so that will be what that would have been your B3. And hence जैसा आपका पूरा रो है आखिरी तक सारे इसमें computation करना है. Similarly, next step will be to find C1. अब इसका next row बनाना है. Next आएगा यहाँ पे coefficient C1. What will be C1? Same thing. अब जैसे हमने B1 के लिए इसके ऊपर की दो रोज को चेक किया था, C1 के लिए इसके ऊपर की दो रोज में सेम ऑपरेशन करना है. B1 into A3 and it's going to be B1 into A3 minus A1 into B2 divided by B1. So B1 into A3 minus A1 into B2 divided by B1. That will be C1. Similarly, C2 क्या हो जाएगा? B1 into A5 minus B3 into A1 divided by B1. Okay. So this will be your C1, C2. Similarly, यहाँ पे C3 भी आ सकता है and so on. And you have to repeat all these steps. You'll have to repeat all these steps जब तक आप s to the power 0 तक नहीं आ जाते. तो यहाँ पे your coefficients can be d1, d2, then it can be e1 and so on जब तक आप s to the power 0 की रो तक नहीं आ जाते. So this is how you form the Routh array. Okay, so this is the formation of Routh array. But our aim was to determine the stability of the system. Routh array तो बनाना सीख गए, but how to find the stability of the system? So the condition for stability of the system using the Routh array is that first, if there are no sign changes in the first column of the Routh array, then the system is stable. So यहाँ पे जो आपको दिखाई दे रहा है, यहाँ पे हमने बनाया ये पूरा Routh array and we'll get the some values. Okay, यहाँ पे आपको कुछ numerical values दिखाई देंगी. All are coefficients, hence you will get some values, numerical values. So what this is saying is, if there are no sign changes in the first column of the Routh array, so this is the first column of the Routh array, A0, A1, B1, C1, D1, E1 and so on. So this is the first column. Okay, if there are no sign changes, then the system is stable. तो आपको इसमें ये भी नहीं चेक करना है कि वैल्यू क्या है. यू जस्ट हैव टू चेक वेदर दिस फर्स्ट कॉलम इट्स हैविंग एनी साइन चेंज. साइन चेंज मीन्स सपोज योर A0 value it's positive, A1 is positive, but B1 if it becomes negative, and then C1 again it becomes positive, then you can say that there is some sign change. पॉजिटिव से नेगेटिव में साइन चेंज हुआ है, देन नेगेटिव से पॉजिटिव अगेन साइन चेंज. तो यहाँ पे अगर कहीं पे भी आपको साइन चेंज दिख रहा है तो सिस्टम अनस्टेबल हो सकता है. इफ देर आर नो साइन चेंज तो योर सिस्टम इज स्टेबल. So this is the condition for stability. And second thing, if there are sign changes, अगर sign change हो रहा है, then the total number of sign change will indicate the total number of poles lying on the right hand side of the S plane. So as I was showing कि जैसे सपोज ए नॉट पॉजिटिव है, ए वन पॉजिटिव है, बी वन नेगेटिव है, सी वन पॉजिटिव है, डी वन सपोज फिर पॉजिटिव है, ई वन भी पॉजिटिव है, एंड दिस इज योर फर्स्ट कॉलम. सो यू कैन सी दैट दो साइन चेंज आया, एक पॉजिटिव से नेगेटिव, दूसरा नेगेटिव से पॉजिटिव. सो टू साइन चेंजेस हैव बीन ऑब्जर्व्ड. एंड तो जो आपका सिस्टम रहेगा, अगर दो साइन चेंज हो रहे हैं, दैट मीन्स देर आर two poles, there will be two poles that will be lying on the right hand side of the S plane. Okay, so example, if n is the total number of poles, so अगर हम example लेते हैं कि एक आपका सिस्टम दिया हुआ है जहाँ पे s to the power 5 है plus s to the power 4 plus s to the power 3 plus 2s square plus s plus 1 equal to 0. Suppose this is the system that is given to you. This is the equation of the this is the characteristic equation. Then you can definitely say that the total number of poles are going to be 5. n की वैल्यू आपकी 5 आ जाती है. And if you form the Routh array for this system, suppose I have not calculated, I am just assuming कि अगर हम इसको solve करते हैं and you find that there are two sign changes, that will mean that there will be two poles lying on the right hand side of the S plane. So that would mean that how many poles are lying on the left hand side of the S plane in that case. So if 5 is the total number of poles, दो पोल आपका राइट हैंड साइड में जा रहा है, दैट मीन्स 5 minus 2, that is 3 poles will be lying on the left hand side of the S plane. So with the help of Routh array, you can actually determine the stability कि आपका अगर साइन चेंज हुआ तो सिस्टम डेफिनेटली अनस्टेबल है, अदरवाइज सिस्टम स्टेबल है. ठीक है, अगर अनस्टेबल है तो हमको ये भी नॉलेज पता चल रही है कि कितने पोल्स आपके लेफ्ट हैंड साइड में है, कितने पोल्स आपके राइट हैंड साइड में है. बट इफ समवन आस्क्स यू दैट कौन से पोल्स आपके लेफ्ट में है, कौन से राइट में है, या उसका वैल्यू क्या है, कैन यू डिटरमाइन दैट फ्रॉम हियर? द आंसर इज नो. You cannot determine which pole is lying on the left and which pole is lying on the right hand side. That knowledge is not given by Routh-Hurwitz criteria, and this is one of the disadvantage also of this system. But अगर आपका एम सिर्फ इतना है कि आपको डिटरमाइन करना है स्टेबिलिटी, और you just want to know कि कितने पोल्स कहाँ पे लाई कर रहे हैं, that you can easily determine from Routh-Hurwitz criteria. Okay, so in that way it's very helpful. And to give you a greater insight to it, let's look into few examples. We'll solve some examples so that you understand how to actually do it. Okay, how to make the Routh-Hurwitz criteria and how to determine the stability of the system. So here you can see we have taken characteristic equation. The characteristic equation is given as q is equal to s to the power 4 plus 8s cube plus 18s square plus 16s plus 5. And you actually have to determine the stability of the system, okay, using Routh-Hurwitz criteria. So as I told you, the first step is to form a Routh array. You have to start writing from the highest polynomial. You have to write, first of all you have to make a column, like first one is your s to the power 4, then write s cube, then s square, then s to the power 1, going up to s to the power 0. Okay, this is your first column that you form for the Routh array. Next you have to write the first two rows, and the rows have to written in such a way that the coefficient of highest degree, you have to write that first. So uh, this coefficient is 1, so I can write here 1. Then next one, it should come below this. So this is s cube, coefficient is 8, so I'll write 8. Third one, it will come again on the first row. So third s square, iska coefficient it's 18, it will be written over here. Next down, so 1, 8, then 18, then 16, then I'll write 5. Okay, so all the coefficients have been written. Okay, now what to do? Now what we have to find out? Now we have to find out actually, so this is 1 and this is 16. Now we have to find out B1, we have to complete this array. So there I had written this was A0, this is A1. Okay, so here now you have to write down B1. And how to find B1? B1 means it's actually, first you have to multiply this two. So 8 into 18, it's going to be 8 into 18. Then minus product of these two, so it will be 1 into 16. Okay, and then divided by 8. This is going to be B1. So 8 into 18, that's 144 minus 16. Okay, 144 minus 16, it's 128. 128 divided by 8. So 128 divided by 8, it will give you, the value will be equal to 16. Right? So this directly also I can write, by solving this I can write this value is going to be 16. Similarly, next 8 into 5, that is 40, minus 1 into, here nothing is mentioned and so I'll take this as 0. So 8 into 5 is 40, minus 1 into 0 will be 0, divided by 8. So it will become 40 divided by 8, and the next term will come out to be as equal to 5. Okay, next term will come out to be equal to 5. So the next row again we have to write the coefficients over here. These are missing. So the coefficient, the value over here, it will come as 16 into 16. Okay, 16 into 16, 256, minus 8 into 5. So it will become 40 divided by 16. Okay, so this actually 256 minus 40 divided by 16. Just find out what's going to be the value. It will come out to be equal to 13.5. Okay, it will come out to be equal to 13.5. Similarly, the next term 16 into 0 minus 8 into 0 divided by 16. तो यहाँ पे कुछ भी वैल्यू नहीं आएगी. 16 into 0 minus 8 into 0 will become 0 only. So this term will become now 0. And so even after this also terms will be 0 only. No need to write it down. Next, this last term, what will be this term? 13.5 into 5 minus 16 into 0 divided by 5. 13.5 into 5 divided by divided by 13.5. So it will come out to be equal to 5. Okay. So now you have to look into this one. कि ये आपका first column है for this Routh array, and you have to actually check this column. What are the values? 1, 8, 16, 13.5 and 5. These are the values that you are getting. Now check the sign of this. This is positive, 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 positive. Are there any sign changes involved here? कोई भी साइन चेंज दिख रहा है, यू डोंट हैव टू बी कंसर्न अबाउट एनी अदर टर्म, यू ओनली हैव टू लुक इनटू द फर्स्ट कॉलम. ओके, यहाँ पे कोई भी साइन चेंज अगर दिख रहा है तो सिस्टम आपका अनस्टेबल होगा. इफ देर आर नो साइन चेंजेस देन वी कैन ईजिली डायरेक्टली से दैट द सिस्टम इज स्टेबल. सो यू कैन राइट हियर एज देर आर नो साइन चेंजेस, the system is of fourth order, hence it will be having 4 poles, and all the 4 poles, they are lying on the left hand side of the S plane, and we say that the system is going to be a stable system. So this is how you can easily determine the stability, and we have not actually found out हमने इस equation का actual में क्या roots है, we are not finding that out. Without finding the actual roots, we are determining the stability of the system. So let's look into another example. So here I have taken QS. Again, it's given the characteristic equation. Okay, this is equal to 0. This is the characteristic equation. And for this, you have to find out whether the system is stable or unstable. So we'll quickly do it. Again, first of all, write the first column. जो आपके highest power of coefficient, highest power of s है, वहाँ से आप s to the power 0 तक इसको पहले बनाना है. So s cube, then s square, then s to the power 1 and s to the power 0. Then write the coefficient. Coefficient is 1, 1, 3 and 5. So 1, then 3 and then 5. That's it. यही coefficient है. ठीक है. अब इसमें नेक्स्ट एस टू द पावर 1 ये वाला रो आपको फिल करना है. दिस इज गोइंग टू बी व्हाट 1 into 3 minus 1 into 5 divided by 1. Okay, 1 into 3 is 3 minus 1 into 5 is 5. So 3 minus 5 divided by 1. So this is going to be minus 2. Okay, आगे कुछ है नहीं इसलिए this will be 0. Next, this term, it's going to be minus 2 into 5, that is minus 10, minus 0, so it's minus 10, divided by minus 2. So it's minus 10 divided by minus 2, that means it's going to be equal to 5. ठीक है, तो अब आपके यहाँ पे फर्स्ट कॉलम में क्या टर्म्स आ रहे हैं? द फर्स्ट कॉलम टर्म्स आर 1, 1, minus 2 and 5. So this is positive, this is positive, this is negative, this is again positive. Are there any sign changes? Yes, definitely. यहाँ पे दिख रहा है. This is positive, positive, negative, positive. There is one sign change from positive to negative, another from negative to positive. So we can say that there are two sign changes here over. Okay. अगर two sign change है, that means two poles are lying on the right hand side of the S plane. And how many total number of poles are there in this system? So here you can see s की power 3, that means we have 3 poles. So the number of poles for the system is 3. 2 poles are lying on the right hand side. So how many poles are lying on the left hand side? There is only one pole which is lying on the left hand side. This is all that we can comment over here right now from the Routh-Hurwitz criteria. Okay, this is the only thing that we can understand. System is definitely unstable, having 2 poles on the right hand side and 1 pole on the left hand side. Next question, it's given QS is equal to S to the power 4, 5S cube plus 5S square plus 4S plus K. So here जो s to power 0 है इसका कोएफिशिएंट नहीं दिया है, it's written as equal to k. We have to find k for the system to be stable. So you have to actually determine what should be the value of k for the system to be stable. कुछ नहीं, हम वैसे ही सेम मेथड फॉलो करते हैं. s4, s cube, s square, s to the power 1, s to the power 0. Then we'll quickly write all the coefficients. So it's 1, 5, 5, 4 and k. And let's make Routh array along with this k only. So first coefficient यहाँ पे जो आएगा, यहाँ पे value जो आएगी, it will be 5 into 5, 25 minus 4. So 25 minus 4 is 21 divided by 5. So it's going to be 21 divided by 5. Next, this one, ये क्या होगा? 5 into k minus 1 into 0 divided by 5. So it's going to be 5k divided by 5, that is going to be k only. तो ये आपका आ जाएगा k. Next over here, यहाँ पे क्या आएगा? This is going to be 21 by 5 into 4. So 21 by 5 into 4, it's going to be 84 by 5. Minus 5 into k. So this is minus 5 into k divided by 21 by 5. ठीक है, this is your this is the term that you are getting for this row, s to the power 1, and now for s to the power 0 it will be this multiplied by this minus this into 0 divided by again this. तो ये वैल्यू आपकी again it will come out to be equal to k. Okay, so this is the Routh array. हमने k की वैल्यू कुछ सब्स्टिट्यूट नहीं की है, हमने k की वैल्यू लेकर के ही Routh array बना दिया. Now we have to find out the value of k for the system to be stable. We know that for the system to be stable, this first column that we get in Routh array, it should be having all the signs positive. मतलब सब कोई sign change नहीं होना चाहिए. That means यहाँ पे देख रहे हैं 1, 5 इनकी values तो positive ही है. That means we want all these values to be positive only. Only in that case we can say that the system is going to be stable. अगर यहाँ पे जो चीज़ unknown है that is this term and this term, we don't know the value of k. अगर ये वैल्यू नेगेटिव हो जाती है then there is going to be a sign change, और साइन चेंज हुआ इसका मतलब आपका सिस्टम अनस्टेबल हो जाएगा. So we can comment that all the values in this first row it should be positive. Okay, and if it should be positive then we have only two components over here, two terms, just those are unknown to us. So we can say that for the system to be stable, this term and this term it should be positive. So first condition k it should be definitely greater than 0. ये जो last term है it should be greater than 0. In that case the system will be stable. Another one, 84 divided by 5 minus 5k, this should be also greater than 0. ये condition भी satisfied होनी चाहिए. तो अगर ये condition है we can write that 84 minus 25k it should be greater than 0, or we can write 84 should be greater than 25k, or we can write that k should be less than 84 divided by 25. ठीक है, यहीं से निकल के आ जाता है कि k की वैल्यू होनी चाहिए लेस देन 84 by 25 एंड k शुड बी ग्रेटर देन 0. ये दोनों कंडीशन सेटिस्फाई होनी चाहिए. सो वी कैन ऑल्सो राइट दिस, ये दोनों को अगर क्लब कर देते हैं ये और ये इक्वेशन, इन दोनों को क्लब कर देते हैं तो क्या आएगा, we'll get that k it should be less than 84 by 25 but it should be definitely greater than 0. So if this k it lies between in this range, इस k की वैल्यू कुछ भी हो which is lying in between 0 and 84 by 25, then we can definitely comment that the system is going to be a stable system. And this kind of stability where you can see that this stability is dependent on k, some parameter k, इस पे depend कर रही है stability. तो यहाँ पे हम बोल सकते हैं कि system is conditionally stable system. This system is known as a conditional stable system because there is a condition applied to it. k की वैल्यू इनके बीच में आएगी तभी स्टेबल है, अदरवाइज इट्स गोइंग टू बी अनस्टेबल. सो दिस इज अ कंडीशनली स्टेबल सिस्टम, जो हमने पिछले बार डेफिनेशन में देखा भी था कि कुछ सिस्टम्स आपके कंडीशनल स्टेबल होते हैं. सो दिस इज हाउ systems become conditionally stable because they are based on certain parameter, they are dependent on certain parameter.